Today, inshallah, we will continue section 4.3. We just, I think, had a short introduction for this section in the previous class. So let's remember together, what are the main objectives of this section? So after finishing this section, you will be able, inshallah, to identify the logarithmic functions, what they are, how to evaluate them, and how to sketch the graph also. And we will mention also the common logarithms, what they are, and what are the natural logarithms. I believe that you still remember from the previous class that we defined the logarithmic functions as the inverse of the exponential function. If someone asks you, what do you mean? What are the logarithmic functions? They are the inverse of the exponential function. So if you have a to the power y equals to x, this is equivalent to saying that the logarithm base a of x equals to y. Again, we still have here a is greater than 0 and a is not 1. The same base that we mentioned in the exponential function. So how to think about the logarithm? The log base a of x is just the exponents to which the base a must be raised to give x. And we mentioned yesterday that we have two forms, the logarithmic form and the exponential form. You can go from here to here or from here to here, wherever you want. We mentioned, of course, some examples about that. We also solve more evaluating. We evaluated more logarithms at different spaces. I believe that we stopped maybe with you, but with other sections we continue. In the recording of yesterday, we mentioned this. The composition, you remember the composition between the function and its inverse, which we call the inverse function property or the cancellation property. Of course, here x, it needs to be in the domain of the function, which is the range of the inverse. And x here, it needs to be in the domain of the inverse, which is the range of the function. So this x is not the same as that x. So if we are talking about the exponential function and its inverse, the logarithmic function. So according to this, their composition will give you x also. For example, here, if we apply, let's apply it here for this one, f inverse of f of x. How it will be here? What is f inverse? Log a. And instead of x, we will write f of x, which is a to the power x. So this gives us what? This will give us x, because we compose the function with its inverse. F inverse of x will give us what? What is f? F, it is a to the power x. Instead of x, we will have log a of x. Now these are two inverses, so they cancel each other. Okay, so we will get x. But of course, this x is not the same as that x. Be careful. X here is any real number. You agree with me? Yes. But x here, it must be greater than 0. Why? Because it's exponential. This x, it is in the domain of the exponential function. What is the domain of the exponential function? All the real numbers. But this x, it is in the domain of the logarithmic function, which is the range of the exponential function. What is the range of the exponential function? Only the positive numbers. Okay. So these are some properties of logarithms. I think it is clear for you that log a for any base a greater than 0, not 1, of 1 is what? A to the power what equals to 1? 0. Similarly, log a of a is 1. A to the power what equals a? 1. And here the cancellation properties that we mentioned. Okay. So let's start with you, please. Over there, log 5 of 1. Why? 5 to the power 0 is 1. Yes, you are right. This is property number 1. Next, please. Log 5 of 5. 1. Why? This is property number 2. And log 5 of 5 to the power 8, it is 8. This is the cancellation property, the inverse function property. The same for the last one. Okay, notice here that 5 is the base. This is different from 5 log 5 of 12. This is 5 all to the power 5. The power here, the logarithm is in the exponent. Great. I believe that you can solve the first recitation exercise. Please try to solve by using just the definition of the logarithmic function. You can here find the value of x. Solve A first. So easy. You obtain it? Yes. What is x in the first one?
5.
It is natural to ask yourself, x, what is the base that if you raise it to the power 2? So to solve this, you need to write it in the exponential form. So this is the trick. How to solve this? This will be x to the power 2 equals 25. From where we obtain this one? From the definition of the inverse. Log a of whatever, let's say b equals to c. This is equivalent to, this is f and only f, a to the power c equals b. Now this is exactly what we mentioned here. Of course, here there are two conditions on x. What they are? X is what?
Bigger than 0.
Greater than 0 and not 1. This is clear because it is the base. So x here cannot be 0, cannot be, it is greater than 0, it is a positive and not 1. Of course, it will not be 1, but just this is for you to remind yourself. Now, x squared equals 25. You will take the square root of both sides. X equals to what? 5. Why we didn't say -5? It is not an acceptable value. We cannot accept that value.
Doctor,
Yes.
Is it because of the logarithm or exponential?
The exponential. It is indeed coming from the inverse of the exponential function. It is not coming from here. It is from the exponential. Yes. It cannot be negative. Don't forget that. Okay. So x is 5 in the first example. Please. The second one. Yes, please, over there. What is x?
X is equal to
-2 over 3. Do you agree with him?
No. Yes.
What is your answer?
-1 over 6.
-1 over 6. We have two answers, -1 over 6 and -2 over 3. What do you think? It is -2 over 3. You had a small mistake in the calculation. It is important to check the concept first. Did you apply the concept in the right way? If you had a mistake in the calculations, you need to be careful when you solve. Again, the main idea is to write it as a jet in the exponential form. Can you give me the exponential form here, please? How to write this in the exponential form? Oh, we have two sajjads here. Yes. It's I mean this one, please. Sajjad al-Habib, is this your name? Yes, please. This is what? 7 of 1 over 49 equals to 3x. How to write it in the exponential form? 7. No. Let me remind you, Sajjad. If you have log a of b equals to c, the exponential form, this is the logarithmic form. The exponential form will be what? A to the power c equals to what? B. So if you have this, you can write it this way. If you have this one, you can write it this way. So what do you think here? So how to write this in the exponential form? It will be what? 7 to the power 3x, you're right, to the power 3x equals to 149. So it is about the base. This is called the base. This is called the argument. So it will be a to the power c equals the argument. Now it is what? Exponential equation. Now you need to think about it, how to use the property that says if you have a to the power b equals to a to the power c, this will happen if and only if b equals to what? C. So we need the same base here. So here we have 7. What do you think here? What will be the base here?
7 to the power minus 2.
In fact, this is 7 to the power 3x equals to 1 over 49. 49 is 7 to the power 2, right? Which can be written as 7 to the power negative 2. Again, you still have a problem with negative and minus. I mentioned this yesterday. It's okay. Now we have the same bases. The same base here, the same base here. So since the bases are the same, then the exponents must be the same. So we conclude that 3x equals to what? Indeed, you can think about it in a different way. You can just take log 7 of both sides. Look what will happen if you take log 7 of both sides. You know that these now are inverses of each other. You know that log a of a to the power x equals to x. So this is now will be cancelled each other and you will have 3x equals to negative 7. But I think it is much more clear without logarithm, okay? But you need to keep this in mind because in some situations, when the bases are not the same, you need this. So if the bases are not the same, you need to apply log for both sides. We will see that in section 4.5 at the end of the chapter. Okay, so we have here 3x equals to negative 2, which implies that x equals what? Negative 2 over negative 2. Where were your mistakes?
I took the square root of 7. I took 7 to the power minus half.
Yes. It's okay. Okay, so we learn from our mistakes. Excellent, guys. Let's continue now. Are you now interested about knowing how the graph of the logarithmic function looks like? I think you know that we said this in section 2.8, how to obtain the graph of the inverse from the graph of the function. The graph of the inverse is obtained from the graph of the function by reflecting in the line y equal x. So now you know the graph. Let's say that we have here log a of x and a is greater than 1. So the graph of the exponential function, if you have y equals to a to the power x, this is the graph, right? Now, if you want to have the graph of this function, what you need to do, just you need to imagine the line y equals x and reflect this line here, this graph. Reflect this graph in this line. You will start with this point. This point is what? 0 and it will be here what? 1 and 0. So it will be here. Now every point, other point will be reflected and the graph will be like this. This is the reflection of the graph. So this is the graph of y equals to log a of x when a is greater than 1. Yes. Yes, we defined the logarithmic function to be the inverse of the exponential function. Excellent. So the graph of the inverse is obtained by reflecting the graph of the exponential function in the line y equals x. Here it is. The blue graph is the exponential. The red one is the logarithm. So now you know also that the domain of the inverse will be the range of the function and vice versa. So just look at this function. What is the domain? What is the possible values of x? X is greater than 0. So the domain is from 0 to 0 is not included, which means that the logarithmic functions are not defined at 0. You cannot evaluate the logarithmic functions at 0. The range, you can see the range. Y is what? Y is from negative infinity up to where? up to infinity. So the range, which was in fact the domain of the exponential function. Look also what is the difference now. What was here, the horizontal asymptote in the case of the exponential. Now we have what? We have vertical. We have vertical asymptote. The graph cannot never intersect the y-axis. It will be just asymptote. When x goes, in fact, what is going on? When x goes or approach 0 from the right, this is the meaning of this. The function, the y goes to where? To negative infinity. What was your question? Yes. Yes. It is a vertical asymptote, but it doesn't mean that -1 also is not included, but it is not a vertical asymptote. Okay? Yes. Here 0 is a vertical asymptote because when the function approaches from the left or from the right, the function goes to infinity. When x approach 0 from the right, what is going on? The function goes. This is the definition of the vertical asymptote. Okay, so notice also something here, that when x greater than 1, look, when x greater than 1, the logarithm is what? When x is greater than 1, log a of x is what? Positive, greater than 0. It is increasing always when a is greater than 1. But when a, let me change the color. When, look here, when x is between 0 and 1, when x is less than 1, but of course greater than 0, it cannot be less than 0. What is going on? The graph is below the x axis, so the logarithm of a of x is less than 0, and this fact I have mentioned it here. Now, you know how to sketch the graph of this one. It is just the reflection of the graph of what? 2 to the power x in the line y equal x. But if you want to use plotting points, you can, just for the first time, but after that you don't need it. So if you select some values of x, and here you have to be careful when you select the values, you need to select 1, 2, 2 to the power 2. You need to select multiples of 2, raised to the power, to be able to evaluate them. If you plot these points, you will get a graph like this. But again, you don't need to do that. Just keep in mind, if you have a logarithmic function, if I give you y equals to log a of x for any a greater than 1, what you will do? Its graph will be like this. No need to plot points, no need to make a table of values, no need for anything. These are some examples about a family of logarithmic functions. Again, notice that they look like each other. Just it will be more close to the x-axis when the base is bigger. So if you have more and more, it will be close from the x-axis. All of them are passing through the point what? 1 and 0. Why? Because log a of 1 equals to what? 0 for any a greater than 1, greater than 0, not 1. Okay. What else? All of them are increasing if a is greater than 1.
Doctor,
Yes.
in this function, can we do reflection on the y-axis?
We will do that. We will do that. Yes.
Can we go back?
Yes.
I didn't understand the condition that is bigger than 1.
This is coming from the exponential function.
Range of
The exponential function a, do you remember a to the power x when we define the exponential function? A is greater than 0, a is not 1. The same conditions here for a, for the base. Now let's summarize. This is the logarithmic function. The domain is only the positive numbers. X here, what is inside the logarithm must be positive. This means that logarithms can be found for positive numbers only. We cannot evaluate the logarithm for negative or 0 values, just for the positive numbers. This means in general, if you have logarithm of any function, whatever inside, This will be defined what? What will be the domain? The domain of this function will be all the values of x for which what is inside the argument is greater than what? 0. So here it is. This is the condition. So if you want to find the domain of any function, if any logarithmic function, just put what is inside greater than 0. How to find the vertical asymptote? Do you remember what was the vertical asymptote for this? The vertical asymptote, it was y equals 0 or x equals 0? X equals 0, the y-axis. So in fact, just put the argument equals to what? To 0. So if you want to find the vertical asymptote of this function, what you will do? You will just put g of x equals to what? Solve it for x, and you will be able to find the vertical asymptote. This has been mentioned also here. To find the vertical asymptote, just put the argument equals to 0. The range, as we mentioned, it is from negative infinity to infinity. This is the graph. If a greater than 1, what do you think how the graph looks like if it is less than 1? By the way, no need to, we will not focus on the case a less than 1 greater than 0 because we can obtain it from here. Do you remember? Let's go back to the exponential functions. When a greater than 1, what was the graph? Like this, right? So its inverse will be like this one, right? Because the line here y equals to x. So this is the log. This is the same graph that we have here. Now, what about when we have a to the power x, but a is greater than 0, less than 1, which means, in other words, we have y equals to a to the power negative x and a greater than 1. It is the same as this graph, but reflected in the y-axis. So it is like this. Now, what will be the reflection of this line about y equal x? It will be like this, right? And here it is. This is the graph of the logarithmic function when the base is what? Between 0 and 1. By the way, if you notice how this obtained from this, it can be obtained from this one. How? Reflecting about the x-axis. Look, just think about this one. Look at this one. Reflected now here. What is below will be above. What is above will be below the x-axis. You will get this one. So indeed, this graph here, when a between 0 and 1, is the same as the graph of negative log a of x when a is greater than 1. So this is why, don't worry about this. I ask you, I argue you to focus on this one. You can obtain everything if you just know this. If you want to find something like this, just remember that to reflect it in the x-axis. So here we have it increasing. This one will be decreasing over its entire domain. The vertical asymptote is the y-axis. All of these graphs passing through the points, what? 1 and 0, 1 over a and negative 1, a and 1. The opposite of the points that we mentioned in the exponential functions. Let's see now some graphs. This is what we have mentioned here, similarly to this. Negative log 2 of x. By the way, who can tell me this is log what? Log what of x? Log half. Believe it or not, this is the same of log. So if I asked you to draw or to sketch the graph of this one, just write here, it is negative log 2 of x. And just you need to remember this graph. To avoid any confusion, Shabab, focus on the graph when a greater than 1. So what you will do to sketch the graph of negative log 2 of x? You will sketch the graph of log 2, then reflected in the, this is the graph of log 2 of x, reflected in the x-axis, you will get negative log 2 of x. Now you can find the domain, the range, the asymptotes. What is the domain? It is still from 0 to infinity. The range from negative infinity to infinity. The vertical asymptote, x equals 0, the y-axis. Excellent. Now for the second one,
It will be reflected across y-axis.
It will be reflected in the y
In the y-axis.
axis. The domain
From 0 to negative.
from 0.
Sorry, from negative
Negative
infinity to
infinity
0.
to 0.
Here x guys, what is inside? What is inside must be what? Must be positive. So x here must be negative. Negative times negative will be positive. So now let's focus on this. We said we will start with the graph of what? Of y equals to log 2 of x. Then we will do what? We will reflect it in the. So this point that is here at 1, it will be where? At negative 1. The graph will be like this. This is the reflection in the y axis. Clearly, it is clear for this graph that the domain is what? All the negative values of x. For the range, all the real numbers. The vertical asymptote still the same vertical asymptote. Excellent. Let's do some vertical and horizontal shifting. How to sketch the graph of 2 plus log 5 of x. You will start with log 5 of x, then shift it up to units. Here we are. And this will go like this forever. This will go like this forever, of course. Now this is log 5 of x. This is log 5 of x plus 2. Now the domain still greater than 0 because the argument doesn't change here. The range still the same. The vertical asymptote still the same. Okay. What about the second one?
Teacher,
Yes.
horizontal shifting, the demand range doesn't change.
Because we have the range from negative infinity to infinity. This is why it doesn't change.
And
Even if we have vertical. Yes. Because it is the whole real numbers. Look at the second one. Now because of the horizontal shift here, the vertical asymptote will be changed, the domain will be changed. So what I advise you, if you have a question like this, y equals log 10 of x minus 3, I advise you to sketch the graph of this one. What you need to do? First of all, find the vertical asymptote. What is it? How to find the vertical asymptote? Both what is inside, both the argument equals to what? To 0, solve it, you will get x equals to 3. So you will go, let me do it here for you. This is the vertical asymptote. Now the graph will be to the left or to the right of this line. Okay? How to know? You need to find the domain. How to find the domain? The domain of this function will be all the values of x for which x minus 3 is greater than, which means x greater than 3. So the graph will be here. And there is no reflection, as you can look here. So it is the same graph like this one. This point will be what? No, the 3 is here. It will be 4. You remember the graph? This is 0, this is 1. The graph will be like this one. So you can now sketch the graph without thinking about the horizontal shift. But of course, the another way is to sketch the graph of the original function, then shifted what? 3 units to the right. So it will be, this is 2, this is 3, this is 4. So the point of intersection will be here. Okay, this is 4. But the horizontal also asymptote that was at 0, it becomes now at what?
3.
At 3. So you can do it this way or this way, but I prefer this one. Because here you will make sure about also the domain, the range, the vertical asymptote. You will not do a mistake. But of course, you still have the option to use any method that is suitable for you. Clear, Shabab? So now the domain has been affected by the horizontal. So the domain will be from 3 to infinity. The vertical asymptote is x equals 3. The vertical line x equals 3. The range is still all the real numbers. There are some solved exercises also here for you to practice. We have 3 graphs here. I will leave it for you, Shabab, to practice. Try to sketch the graph and then compare your solution with the full solution. We have here, just for short, to keep the notation, when you have log 10 of x, it is shorter and clearer to just write it like log x. without 10. So wherever you see log x, it means that the base is what?
10.
10. If the base is not mentioned, this means that the base is 10. So easy. So this is why they call it common. It, in fact, because of, you know, that we use the decimal number system. Our number system is the decimal system. So this is why 10 is the powers, the base of the powers of all the denominators when in the case of decimal numbers. So the logarithm with base 10 is called the common logarithm, and it is denoted by this. So what is log 10? Again, you need to, for a while, you need to remember that there is a 10 there, okay? But after that, of course, you will get rid of it. So it is 1. What is log 100? 2. What is log 0.1? -1. What is log 0.01? -2. And what do you think its graph will look like? The same. It is the same. No need even for table of values, just the same. Just here, ya shabab, if you want to know that is it wider like this or narrower, that if you want to sketch the graph in the exact way, just look at the base. At the base, it should be what? So here, when the base is 2, it will be 1 here. So the graph will be like this, if it is 2, and so on.
Yeah.
Okay. I believe that you can sketch the graph of this function. What is the base here? The base is 10. It is not mentioned, so it is 10. Please try to sketch the graph of this function. During that, I will take the attendance and pause the recording. Resume recording. So what we will do here, what I advise you to do is to start with log. I advise you to start with log x, and you know how to sketch the graph of log x, right? Then reflected in the go to the graph of y equals negative log x, and this is what we have. You will reflect it in the y-axis. Then what? Now the mistakes come here now. What you need to do, you need to follow the order of operations. Don't forget that. Start from inside to outside. So now we have here what? We have 1 minus x. In fact, you can think about it like minus x plus 1. Is this shifting to the left or to the right?
To the right.
In fact, this is minus x minus 1. If you take negative as a common factor. So this is shifting to the right, not to the left. If it is x plus 1, this is to the left. If it is minus x plus 1, this is to the right. So this is to the left, this is to the right. We are replacing here not x by x plus 1. No, we are replacing x by x minus 1. So now what will happen here? We will just shift this one to the right. So it will be, instead of being here at -1, it will be where? This point will be at 0. The vertical asymptote, instead of being at 0, it will be at 1. Here it is. So this is why in such equations, ya shabab, I advise you always to start by finding the vertical asymptote. This is vertical asymptote. Also, I advise you to find the domain 1 minus x greater than 0, which means negative x greater than -1, which means that x is less than 1. Is that right? So this means this will help you also to know that the graph will be to the left of what? To the left of the vertical asymptote, not to the right of the vertical asymptote. So you can know that your answer is right or not, is correct or not. Is your graph is to the left of 1 or to the right of 1? Okay, let's continue now. So what we will do now? We will reflect in the x axis. Here it is. It will be reflected in the x axis. Then we will shift up what? 1 unit. So now for the shifting, this point is 0 and 0. It will become what? 0 and 1. Here it is, 0 and 1. They still have the same vertical asymptote. The graph is like this. If you want to find the y-intercept, by the way, I make it like this because I want you to see the y-intercept, the x-intercept. The x-intercept is here, is -9. Why? This will be 10 log 1 minus, we need this to be at 0. This is not necessary at this stage, but let me just mention it for you because some of you, they will be aware about it. Now log 1 minus x equals to 1. What is 1 minus x? It is 10. The exponential form, which means that x is what? Negative 9. So this is if you want to find, if he asked you about where it is above the x-axis or below the x-axis. Of course, it is increasing always. Any question related to this, please? Yes.
نقدر نحله بدون رسم الجراف جبريا يعني.
It is about the domain, the range, and the asymptote. If you want what? To solve it algebraically for what? If you want to find where it is above the x-axis, below the x-axis, yes. If you want to know where it is above the x-axis or below the x-axis, you can solve it algebraically. We will do that in section 4.5. But here, he just wants to sketch the graph and find the domain and the range. It is clear, Shabab, that the domain is from negative infinity up to where?
1.
Up to 1 open. And the range is still from negative infinity to infinity. The vertical asymptote is x equals to 1. Yes, please. Yes, please. This is a good question, Shabab. Now, when at this stage here, where okay, let me explain it because it is clear from here. Some of you, they did what? Some of you, they started writing this as 1 minus log negative x minus 1. It is correct, right? Now what they did, they start with shifting. They start with log x, but they shifted to where? To the right. So it becomes like here. Now the vertical asymptote will be here. The graph will be here. Now what they did, they reflected in the, this is 2. They reflected in the, to apply this. Now they reflected in the y-axis. So the graph, their graph becomes, is this correct?
No.
You should, your new vertical asymptote is not the y-axis now. It is what? The line x equals 1. So in fact, you ask yourself when x is 0, when x is negative 1, y is 0. Ask yourself here, if you bought x equals to negative 1, are you going to have 0? No, you will not. So indeed, what is the distance from here to here? 1 to what? To 2. So now you will go also 1 to the left. So it will be here. The graph will be here. So it will be symmetric about the vertical asymptote. You got it? So this is the mistake. If you did this, you will do it in the right way. It is the same. And you can continue doing this for until you have the same graph at the end.
So I should do
You can do this or this. It is the same. You can do what we did or this one. But here, you can start by shifting to the right, then reflect in the line x equals 1. The new vertical asymptote, not the y-axis. I just would like to mention this at the end, Shabab, that the natural logarithm, when the base of the logarithm is e, the natural exponential, shortly we will write this as ln, and it is in fact formally read as lnx, but I used to read it ln. I combine these. So it is up to you if you want to say ln x or lnx, it's okay. So whenever you see ln x, this means that it is log e, log base e of x. And of course, you can apply all the properties that you had before. For instance, what do we mean by ln x equals to y? It means that log e of x equals to y, which means that e to the power y equals to what? To x. Unfortunately, the time is up. We will stop here and continue next class, inshallah. Thank you, and see you tomorrow, inshallah. Yes.